A few cautions you must look for when you're dealing with regression and correlation. The first one is, especially in this course, we're only dealing with linear relationships. An example would be gas mileage. Gas mileage is more of a quadratic relationship. As I increase my speed, the slower I'm going, the lower my gas mileage is. I'm going to increase my speed and I will plateau at a certain level and get extremely good gas mileage, but then the faster I go, it's going to drop off. So that correlation, those two variables are going to be related, but they're not going to be linear. As one increases, one is not also increasing or decreasing. It's going to be a quadratic relationship and look more like a bell-shaped curve. Correlation least squares regression are not resistant, so if you have a strong skew, that will affect both of those values. Extrapolation is when you are trying to predict a value that's outside of the range. And the best example I have for extrapolation is if you're looking at the growth of a child between the ages of 0 and 3, for example. As we all know, a child between the ages of 0 and 3 is growing extremely rapidly. Their height is increasing very consistently, and they're growing much more rapidly than an adult would. If you use the regression equation given from birth to 3 on growth and try to predict the height of a 45-year-old, you are going to have an extremely tall individual that would be an impossibly tall individual. So we cannot use our regression equation to predict values that are beyond our range. Working variables are another caution that we have to look out for, and they affect a relationship but are not necessarily included in the variables being studied. An example would be, I think it was in Britain, they did a study of the number of TVs in homes and how it affected the life expectancy of the individual. And they found out that the correlation between life expectancy and the number of TVs in a household was extremely high. So if I go out and buy 5 more TVs, does that mean I'm going to live longer? Probably not. The reason these individuals were living longer is because they were probably on the higher end of society, they were making more money, they are probably better exposed to healthcare benefits and things like that, where people with 0 or 1 TV are probably on the lower end of the pay scale. They're not making as much money, they're not receiving as good of healthcare and that type of thing. So economic status would be a lurking variable or confounding factor in that situation. And lastly, association is not necessarily causation. Our explanatory variable does not necessarily cause our response. So a strong association is not enough to draw conclusions on our cause and effect.